Bismillahirrahmanirrahim. Welcome to the lecture number 2. The course is the data structure. Before starting the lecture number 2, we need to revise the little bit lecture number 1. So yesterday we have seen this, that what is data structure and the types of the data structure. There were 4 types of the data structure: linear, non-linear, physical, and logical. This physical and logical, it will be clear in the coming slides, inshallah. And then we have discussed some basics definition that will be used in the data structure, like what is bits, byte, the field, character, records, files, and so on. Now, why we need the data structure? Data structure, actually, this is the organization of the data. Mean the data will be organized in a very well manner so that it can easily be accessible and achievable. So when the data is well organized, what will be the output? The output will be the efficient programs. We can develop the efficient programs. If we develop efficient program, so we will have the most and more powerful computers. As we know this thing, that if we have the powerful computer, then it needs more complex applications. Now, complex applications, we know this thing, it need what? It need more calculations. Of course, it has to deal with the large amount of data. So data structure should be used for managing the data. So data should be arranged in such a way that is easily accessible. Of course, this is the goal of the data structure, that the data should be arranged in such a way that is easily accessible. Now, if you use the proper data structure, means if we need the nonlinear data structure in order to solve the problem, and we use the proper nonlinear data structure for that, then what will happen? Then the choice of the data structure and algorithm can make the difference between a program running in a few seconds or many days. If a proper data structure is used, then the running time of the program will always be less, maybe a few seconds. If not, we never use the proper data structure, then wait for few hours or wait for the days. Efficiency. When you are going to solve the problem, then you have to check whether your solution is effective or not. A solution is said to be efficient if it solves the problem within its resources constraints. What does this mean? Look, we have 2 resources. One is called space, one is called time. Space means how much memory it will take. Time means how much execution time it will take to process the data. So it should take less memory and it should take less time in order to execute the program. So the cost of the solution is the amount of the resources that the solution consumes. Maybe you are going to solve the problem, it occupy the less resources. Maybe you are going, if the size of the problem is large, so definitely it will need more memory and more time in order to be executed. So depending upon the size of the problem, efficiency, this means that we have to write down the programs considering the resources to achieve some solution as soon as possible. Yes, of course. So the resources, there is always a cost associated with these resources. Everything has its own cost. Everything has its benefits. Everything has its own some disadvantages. So we need a faster and better CPU which can be purchased. Sometime we may need to buy the memory. Of course, if we are going to solve the complex problem for that, we need a good systems. We need a better CPU for that thing. And sometimes we need to buy a memory. And if the size of the data is very large, so definitely we need more memory for that. As long as data structure and programs are concerned, you have to invest your own time for this. The resources here we are interested is only and only in the time, because we have too much memory, but we don't have a time. We cannot wait. We need to minimize the execution time for that. Now, selecting a data structure. Following points should be kept in mind while selecting the data structure. First thing, analyze the problem to determine the resource constraint a solution must meet. Check the nature of the problem. Check the size of the problem. How much resources are needed in order to solve this particular problem. Second one, determine the basic operation that must be supported. Which operations? As we have seen in lecture number 1, traversing, the insertion, deletion, merging, sorting, and so on. How many operations your problem will be support. Third one, select the data structure that best meet this requirement. Either you have to select the linear data structure, either you have to select the non-linear data structure. Each data structure has its cost and benefits. Definitely, in different situation, different data structure will be suitable. An important skill this course is going to lend the student is the use of the data structure according to the situation. After completion this course, when you complete this course, when you see all the techniques, when you see the implementation, when you see the methods of each technique, you will be able to know when you are going to solve the problem, mean you are going for the development mode. So you will know that I should use which data structure for that. What the beer is doing, of course you guys know, let me know in the comment. Okay, let's start the new chapter, arrays. As we have discussed in programming course, arrays, we have seen some of the code of the array. An array is the list of the finite number of homogeneous data type. Homogeneous means same data type. If you declare the array integer, so all the value will go integer values. If you declare the array float, so the float value should be assigned to the array. If you declare the array as a string data or character, so then character data should be assigned to the array. Keep in mind these 3 points. The element of the array are referred by the index number. Element of the array, every element in the array, it must have the index number. What is index number? Index number is the slot number where the value is stored, or where the value is going to be stored, or from where the value is going to be accessed. The second point is the element of the array are stored respectively in successive memory location. Yes, this is the one of the advantage of the array, that the element are stored after one another. Then size of the array can be obtained by the following formula. Length is equal to upper bound minus lower bound plus 1. Look at the second definition. An array is the collection of the cells of the same type. As I said it previously, so it is the collection of the cells. We go toward here. Look at here. This is the array of size 6, 0 to 5, mean the array has the size 6. And the elements are in contiguous in computer memory. For example, first cell address is the x of 0. Let's say this is the array. Let's say this is the example of the int x 6. Int x6. So int x6 means create this, they occupy these 6 locations in the computer memory. 1, 2, 3, 4, 5, 6. As we have seen in programming course that it is started, the index number is started from the 0, 0, 1, 2, 3, 4, 5. X of 0 is the address of the first cell. X6 mean occupy the 6 cells in the computer memory. X of 0 mean first cell, X of 1 mean second cell, X of 2 mean the third cell, X of 3 mean fourth, X of 4 mean fifth cell, X of 5 mean sixth. Total 6 elements will be stored in this computer memory in this particular array. So collection of cells of the same type. Here I declare integer. So integer value will be stored only here in this one. And elements are referred by the index. Index. Every slot, every cell has its own address. Elements stored in successive memory location. Every element are storing after one another. So the number n of element is called the length of the array. Means how many total number of element can be stored in the array. It is a simple basic formula. Length is equal to upper bound minus lower bound plus 1. If we apply it here, upper bound is where 0. The lower, so the upper bound minus lower bound plus 1. Here the lower bound here is 0 and upper bound here is 5. So if we put the values in this formula, 5 minus 0 plus 1, this is equal to 6. So the length of this array is how much? The length of this array is the 6. Each programming language has its own rule for declaring the arrays. As I told you in the previous course, C++ has its own format for declaring the array. Java has its own format. So for every programming language, it has its own rule for declaring the array. But normally declaration include what? Name of the array. We write down the name of the array. We write down the data type of the array, and we write down the index of the array. Let's go toward here. The previous example, we have seen this thing, int x6. So int is the data type here. Int, integer. All the values come to this array, it will be integers. X is the name of the array, and this is called subscripts. Subscript. Inside in the subscripts, I have written down this 6, which is telling me the size of the array. So it is started from 0, 1, 2, 3, 4, 5. Total, how many elements? 6 elements. Started from 0 till 5. So in the previous example, X is an array name. That was the name of the array. But this is, there is no variable X, and X is not the L value, mean the left value. For example, if we have the code, if I write down int AB, so it is clearly visible A and B are the two integer variable. These are not the arrays. Why these are not the array? Because there is no subscript with this one. Then we can write down B is equal to 2, perfect. A is equal to B, perfect. A is equal to 5, perfect. But we cannot write down the 2 is equal to A. This here is X is not the left value, mean variable is not the left value. Did you get my point? 2 is equal to A. This thing is not allowed. This is not allowed. Go for further example, int x6. X here is the array whose size is what? 6. Int n, n is the variable. If I say x of 0 is equal to 5, yes, perfect. Store the 5 in the first cell. X of 1 is equal to 2, store the 2 in the second cell. If I say x is equal to 3, no, because x is the array, x is not the variable, and it does not have any subscript, any index number. If I say x is equal to a plus b, again this is wrong. If I say x is equal to store the address of the n and n, this again this is wrong, because x I declare above is the array, not the variable. Simple arrays known size of the array at the compile time. Yes, of course. We have seen this thing in the programming, C++ programming. But sometimes it is also not predetermined. If you remember, I told you the static array and the dynamic array. Yes, let's discuss this one. Some programming languages such as Fortran, formula translation, and Pascal allocate the memory for the array statically, i.e. compilation time. Static mean compilation, dynamic mean runtime. So when you declare the array before the runtime, that is called the static. The size of that array is fixed. You cannot change it during the program execution. And so the array size is fixed. It will be remain fixed during the entire program execution. while some programming language allow one to read an integer n that declare an array of the size n. This is called, so that allocates the memory dynamically. So if you declare the variable n and you ask from the user how much size of the array you want in your program, so that particular declaration of the arrays assigning the size of the array is at the runtime, not the compile time. So this declaration is known as what? Dynamic array. Normally simple arrays are called the linear array, like the linear data structure. One of the joke here, the Lion King is hosting an animal conference. All the animals attend except one. So give me the answer in the comment. Yes, of course, elephant. Array has 4 qualities. As we have seen, it should be finite. It should be homogeneous data. Homogeneous means all the elements have the same data type. If this is integer, all the value should be integer. If this is float, all the value should be float. Common index, it must have a index number. In consecutive mean, the element are stored after one another. There are 2 types of the array, one dimension and multi-dimension. One dimension, we know that either the values will be stored in row wise, or either the value will be stored in the column wise. We will discuss shortly in detail this one. Multi-dimension, when the array is referred by the more than one subscript, like 2-dimension array, 3-dimension, 7-dimension, up to n dimension. If I say for the 1 dimension, if we look at here, int x5, it has just only one direction, 5. Either map them in row wise, either map them in column wise. It doesn't create any problem. 2-dimension array, if I say int y3, 2, look at here. No, 3 is the first dimension, 2 is the second dimension. This is called multiple dimension. The first dimension, this represents the number of rows. How many rows will be in this array? So it's saying 3 rows. Second index represents the number of column. How many column will be there? So it says 2 column, mean 3 rows, 2 columns. Sorry, three rows in 2 columns. 2-dimension array in the computer memory. In mathematics, we have seen the example of matrices. And business application, we are seeing the tables. What is row? A row is the horizontal list of the elements. Horizontally, horizontal. This dimension is called the horizontal. This is called horizontal. Column, a column is the vertical list of the element. Like when we study here, column, line. So column is the vertical list of the element. In computer memory locations, array are usually mapped into a vector. For example, let's go for 1-dimension array. If I say int z4, z is the array whose size is 4, and I'm assigning the 4 integer value. The first value is 10, 30, 40, and 100. So how we map it? Either in row wise. Row wise mean 10, 20, 30, 40. Look at the values: 10, 30, 40, 100. 10, 30, 10, 20, 30, 40. Sorry, this has the little bit. Let me correct this one. 10, 20, 30, 40. Yes. So 10, 20, 30, 40. These are the 4 values. Let me save this file. Okay. So the first value is 10, 20. Okay. Index number, slot number 1, slot number 2, slot number 3, slot number. Basically in programming, we normally represent it with 0, 0, 1, 2, 3. It means 4. But for your simplicity, I'm going to start it with 1. 1, 2, 3, 4. In the memory address for this one is 1010, 1012, 1014, 1016. So 10, 20, 30, 40. Which direction is this? This is called row wise. Row, I store the value in row wise. I can also rotate this value to the vertical, means column wise. The same element, the same value we will get. 2-dimension array, logically in the form of the rows and column, but store in the single form of the, but store in the form of the single vector. Either we will store the two-dimensional values in row by row order or column by column order. Row by row order, if you look at here, this is a matrix A, it contains 9 values, 1, 2, 3, 4, 5, 6, 7, 8, 9. Try to understand the point. 1, 2, 3. This is row number 1. Row number 2, 4, 5, 6. Row number 3, 7, 8, 9. Now, what is the address of the one? First row, first column. Then first row, second column. First row, third column. So address of 1 is what? 1, 1. First row, first column. Address of 2 is what? First row, second column. 1, 2. Address of 3 is what? 1, 3. Yes. Address of 4 is what? Second row, first column. 2, 1. Address of 5 is the 2, 2. Address of 6 is the 2, 3. 2, 3. And so on. Same is for here. 3, 1. 7 address is the 3, 1. 8 address is the 3, 2. 9 address is the 3, 3. So we will go toward here like this one. First row, look at here. First row, I will write down the first row, 1, 2, 3. 1, 2, 3. Then the second row, 4, 5, 6, and so on, 7, 8, 9. So address of 1 is what? Address of 1 is the 1, 1. Address of 2 here is the 2 here is the, what is the address of this one? Yes, 1, 2, of course, 1, 2. Address of 3 is 1, 3. First row is finished. Then the second row started 2, 1, 2, 2, 2, 3. Like this, we will map the values. We will map the values in this one. No, if we see logically, it seems logical representation. It seems like this. But when we go toward here, like the other physical representation, it is mapped into this form. Now the first form is different than the second form. Did you get my point? Yes. Okay, accessing methods. Accessing method for accessing the value from the memory. It means when you store the value in the computer memory, how you will access your values again. The first one method is called dupe vector method. Dupe vector method. Second one is Liffey access method, access table, and hashing. There are 4 methods for this one. First one method is dupe vector method. Dupe vector method is an easy, efficient way to access each element of the array using only starting address and subscript of an element for accessing an array element. The formula for the dupe vector method is the memory address I is the value which is going to be accessed, the subscript of an element. I mean, I can be 4. I need this slot number 4 value, cell number 4 value. I can be 2. I need the second cell value. So look at the formula. Memory address, MA mean memory address. I is the particular subscript of the element to be accessed. SA means starting address, mean the memory address, plus I minus 1 multiplied by W, where W is called the word length. For integer, we know it takes 2 bytes. For the float, it takes the 4 bytes. For the character, it takes 1 byte. Look at the example. Find the I is equal to 4 from the given array. Mean I need the value of the 4. How the computer will fetch the cell number 4 value? It is very easy. Formula is what? Formula is the memory address of I is equal to starting address plus I minus 1 multiplied by W. Here, starting address, the computer, the array start from which memory address? 1010. So I need the starting address. Starting address here is 1010. And as this is integer, so integers take how many bytes? 2 bytes. And I need what? Cell number 4 value. Putting values in the formula. MA of 4. MA of 4. I'm going to find out the value of the 4. Let me take the here. Putting values in the formula. So memory address value of I need to find out the value number 4. I is equal to 4. Starting address here is 1010 plus 4 minus 1 multiplied by 2. 4 minus 1 multiplied by 4 minus 1 is equal to 3. 3 multiplied by 2 is equal to 6 plus 1010. It's 1016. It's saying to the computer, go to 1016 memory address. You will have the slot number 4 value or cell number 4 value, which is equal to 40. This is how the computer fetch the data from the memory. Very easy. Okay, now do vector for the 2-dimension array. For the 2-dimension array, as I told you previously, either you will map your data row by row order, or either you will map your data column by column order. The first, let's see for the first one, row by row order. The formula for the row by row order is the memory address of I and j. I is the row number and j is the column number. Starting address plus n. N is the total number of columns here. Total number of columns here. I minus 1. I is the value that is going to be accessed, plus j minus 1. J is the value. No, j is the number of row. I is the number of column here. Multiply by w. Multiply by w. So let's go for this one. Okay. We have a matrix. So map this matrix in row by row order. How are you going to map this one in row by row order? So again, first row 1, 2, 3, then the second row 4, 5, 6, then 7, 8, 9. The subscript for the 1 is the 1, 1, the 2 is the 1, 2, the 3 is the 1, 3, 4 is the 2, 1, address of this one, address of 5 is the 2, 2, address of the 6 is the 2, 3, and so on. Like this one, we will particular map them. We will map them here. So I just map them here, row by row order. This is the row. First 1, 2, 3, 1, 2, 3. Address of 1 is 1, 1. Address of 2 is 1, 2. The memory address for this one is 1, 0, 1, 0. As this is integer, so 2 byte difference. It takes 2 byte. It takes 2 byte 1, 0, 1, 2. It takes 2 byte 1, 0, 1, 4, and so on and so on. So these are the memory address. These are the values mapped in row by row order, and these are the index numbers. So find the value of the second row, third column. Second row, third column here. Second row, third column here. Find this cell value. We know this is 6, but how the computer will fetch the value? Let's go for this one. We know starting address here is what? 1010 plus n. Total number of columns. How many total number of columns? We can see in the question first, second, third. 3 columns we have here. So the value of n is 3. I minus I here is 2. 2 minus 1 plus j is what? J is 3. 3 minus 1 multiplied by w. W is equal to 2. So when we put the values in this one, yeah, click it here. When we put the value here in this one, so how we get it? Let me go for this one. They never did the solution. Let's go do the solution. It's okay. Okay. Do the solution here. Normally we do it here. So this is equal to voting values. Okay, starting address is 1010. Here this is plus, and here this one, n is the 3, and when we solve it, I value of here is what? I here is the 2 minus 1, and here this is the plus. The value of j, here is what? In the question this is 3 minus 1 here, and close it and multiply by w here is 2. So when we normally solve it, what we get it? Yeah, just do it quickly. 2 minus 1, this is equal to 1. 1 multiplied by 3 is equal to 3, and 3 minus 1 is equal to 2. 3 plus 2, 5. 5 multiplied by 2 is equal to 1020, 1020. Yes. So here the 1020, the value at 1020 store here is what? This is the 6. So 6 is my answer. So the 2, 3 answer here is equal to 6. That's the perfect answer for this one. So let's go for the second method, no? Column by column order. So column by column order is the same thing, but we have little change in the formula. Previously here I was taking the total number of columns. Now in column by column, I will take the total number of rows here, reverse of each other. So memory address ij is equal to starting address plus total number of rows j minus 1 plus I, where j is the column, I is the row, multiply by w. So this is the data. This is my data. How we gonna solve this one? Column by column by. So I will write down the first 147, 147. The address of 1 is what? 11. Address of 4 is what? 21. The address of 7 is what? 31. 31 mean third row, first column. 4 is second row, first column. 1 first row, first column. Here, first I will map 147. This is the 147. 147. Here, bring it here. Yes. 147. The address of 1 is 11. The address of 4 is the 21. The address of 7 is the 31. Second one is the 258. 258. The 2 address is what? 1 2. First row, second column. The 5 address is what? 2 2. Second row, second column. 8. The 8 address is the third row, second column, and so on. Here 369. Further is 369. So what will be the address of the 369? The address of the 3 is what? 1 3. The address of the 6 is the 2 3, and the address of 9 is the 3 3, and so on. We can map it like this. And if someone asks, find the memory address of the here the 1 2 mean first row, second column. 1 2 1 2. If someone asks, find the address of the 1 2 1 2. Here I know this thing here, 1 2. The address here is value is 2, but how the computer will solve it? Let's go for this one first. How the computer is going to solve it? So if we come here, providing static address, the value of I here is 1, the value of j here is 2. Starting address is the 1010 in here plus the particular m, total number of rows. If we look at here, how many rows? 1 2 3. There are 3 rows in the question. So 3 rows in here. J minus 1, the value of j here is what? J value is 2 minus 1, and here plus, and here I, the value of I here is 1 minus 1, and here close it and multiply by 2, because these are the integer data. Integer data takes 2 bytes. Okay. Now further, how we go for that? So what is the final answer we get it here? Okay, 1 minus 1 is 0, 2 minus 1 is 1, 1 multiplied by 3 is equal to 3, 3 multiplied by 2 is equal to 6. So 1010 plus 6 is equal to 1016. And address 1016, what is the value here? The value here is 2, so 2 is my answer. This is how the computer fetch the value from the computer memory. Second method is the leafy access method. This method uses the pointers. Through these pointers, elements of the array are directly accessed. This method is faster than the previous method. Faster method, it contains the calculation. This method uses the pointer, just point the memory address only. Access speed is more faster than the previous 2-vector method, but leafy access method is only used for the 2-dimension array, not for the 1-dimension. Pointer contains the actual location of the data. This is my data. So either map them in row by row order. Row by row order, 1 2 3 4 5 6 7 8 9. Yeah, 1 2 3 4 5 6 7 8 9. Address of 1 is what? 1 1. 2 is 1 2. Because this is row by row order. 3 is the 1 3. 4 address is the 2 1. the 22 index number, and 6 is the 23 subscript number. Here, the memory address for this one, slot number 1 address is 11. The memory address for the slot number 1 is the 1010. Okay. Now, row number 1 contain how many elements? 3 elements. And row number 1 started from here 1010. Here I have a pointer which points what the row number 1 from here it started in the computer memory 1010. A total 3 element 1 2 3. It belongs to the first row. Okay, row number 2, it started from the address 1016 in the computer memory. So it point this particular address 1016. Total it contain how many elements? 3 elements. First 1 2 3. Here is row number 2. Row number 3, it started from the question, it starts 7 8 9. So next is 7 8 9. That will come 1022. Here it will start 1022. 7 8 9 contain how many elements further? 3 elements, and so on. If someone is asked, find me the value of the 2 1. So 2 1 2 1 2 is the row number 2. So it will come here 2. In the 2, access the first value. This is equal to 4. Okay, then the column by column. Column first, map the data in column, mean 147 first map it, 258, 369. And so on. So column number 1 contain how many elements? 3 elements, 147. So 147. Column number 1 started from what? 1010. It contained 3 elements. Column number 2, it started from where? It started in the computer memory from 1016. It contained 3 elements. This is the 258. Then the next column number 3, it contained the further 3 element. This is the 369. Next is the 3 by 6 by 9. Same. Then the address for that one will be what? 1022. Here the address 1022. It will start. If someone asks, give me the value of the 32. It comes here. The column number 3, and the second value, first value and second value. We can have it. We didn't draw this one. We can draw it by yourself. 32 here. Let's say this one here. This 32. 32. Here, this is the value 32. 22 and the 32. Here, this is the 32. Give me the value of the 32. So 2 here, the column here is what? Column here is the 2. So come toward here, and it from here the column number 2 start. The column number 2 started from here 1016, and the third value for this one is what? Is the 1020. This is first value, second value, third value. This is 1020. The value here is 832. If it is suppose like it was the 33. So 33. First 3 is the row, and the next 3 is the column. Here in this question, it was 32. 32. 3 is the row and 2 is the column. So I will search it with the help of the column. Why? Because I map my data from the column wise. And let's say if it's suppose by 1 2. 1 2 means 1 is the row number, 2 is the column number. 2 is the column number. So second column, the value here is 1 2. 2 is the column. Second column means go to second column from where it start. 2 1. Sorry, 1 2 means column number 2, and 1 is the access the first value. If this was 3 2, column number 2 access the third value. Like this, computer memory access the value from the using Liffey access method. Third method is the access table. The previous two methods for accessing array elements are used for the numeric data. Yes, for the numeric data. But they cannot deal with the string data. So we need to find out the way how the computer will fetch the value from the memory for the string data. Let's say I have a string array. First value is Asad, Fahad, Aslam, Khalid. It will be stored in the computer. First Asad will store. Asad contain how many words? 1, 2, 3, 4. Here, this one. String number 1. String number 1 is Asad, ASAD. ASAD. So total contain how many element? Four element. So 1, 2, 3, 4. This is string number one. String number one started from address number one. It contain how many values? Four values, four elements. Then string number two. It started from the address 5. In total, it contain how many element? Five element. Five. 5, 6, 7, 8, 9. These are the five elements. Fahad, F-A-H-A-D. This is string number 2. String number 3 is starting from the address 10. Address 10. And string number 3 starting from the total it contains how many elements? 5 elements. S-L-A-M. Salam. Aslam, sorry. Started from the address number 10. 10. 10 is here. This one, A-S-L-A-M. Aslam. We look it here. Here. This is my Aslam. Yeah. String number 4 contain how many element? 1, 2, 3, 4, 5, 6. String number 4 contains 6 element. It started from the address 15. 15. Khalid. K-H-A-L-I-D. So this is how it stores the data in the computer memory and then it accesses the data from the computer memory. The last method for accessing the value of the array is called hashing. The unique key of every record is converted into memory address, and that is called the hashing address. And the formula which is used for converging the unique key into hash address is called the hash function. Okay, unique key. When I'm talking about the unique key, something comes in your mind that I'm talking about the primary number, primary key. That is a unique key. So what is how it stores the values in the computer memory and how it retrieve it back from the computer memory? It uses a method which is called hash function. And the address will be obtained using hash function. Hash function. That address is called hash address. On that address, the value will be stored, and from that address, the value will be accessible. How? Look at here. Record key. I have a primary key. Primary key is divided by total number of values. Let's say I have the array of size 1000, 1000, 1000. So I take the primary key divided by 1000 and I store the value on the whatever is the remainder. I'm talking about the remainder. Whatever is the remainder, baki manda, on that particular address, the value will be stored. Let's go for the example. You will come to know. Here, let's say 3456 3456 is my what? 3456 is my primary key. Divide the 3456 by 1000. You will get what? You will get the 456. Go to slot number, cell number 456 and store the record of the 3456. Did you get my point? Yes. This is how it stored the value. But here, one of the problem in hashing is this, the collision. Maybe we will have the 2 hash address or 3 hash address for the same hash address for the multiple record number. For example, if I have the record number 7066. If I divide it by 1000, baki mandachi mein hai 66. If I have also 8066, baki mandachi amal 66. Ali slot number 66, cell number 66. Azi record value restore kunam, yeah, azi value record restore kunam. This is called collision. Now, how to solve this collision problem? It can be solved with the help of the list. What does this mean? Look, for the first record number 7066, if we divide it by 1000, the remainder we get is the 66. Now go to slot number 66. First store the record of 7066. Then again I get it the 8066. Baki manda chiamat shasto shash. The result of the 66, it will store here. It will store how I'm going to store the next value on the same address. Ali ho yak bar ma value restore kar dam, record number 7066 information unja store kar dam. Ali nobati chiamada nobati 8066. No ma chi bi kar me kuna ma meram the slot number 66 or slot means cell number 66. Maraftan unja yak bar record store as. Ho chi kar me kunam I will check the further available free memory location. हर जगह की memory location free both uramal link में कुनम कती location number 66 Ali link shoda. Ali ma inja value 8066 record store. So this was the solution for this one. How to put the zaraf in the refrigerator? Very simple. Open the refrigerator, put in the zarafa and close the door. Simple. Yeah, that's very easy. Same as for the course. So that's enough for today. If you have any question, you can ask me and you can email me and you can call me directly. Thank you. Allah.